Hello, sixth graders. Today we're going to take a look at what's called complex fractions. Complex fractions are just really nasty fractions, such as 1/2 over 4. So it's when you have a fraction within a fraction. So fractions like that are called complex fractions because they're just really complex. They're not simple like we like them. We normally like them to be whole numbers in the top and bottom. Complex fractions are fractions with a numerator, denominator, or both that are also fractions. So it's fractions embedded within a fraction, essentially. And you'll hear me call them triple-decker or quadruple-decker fractions. In this case, I would call this a triple-decker fraction because I've got 1/2 in my numerator, 4 in the denominator. So I've got 3 numbers. That's why I call it triple-decker. To simplify complex fractions, what we want to do is turn the numerator and the denominator both into whole numbers, back into our regular fractions that we know and love. And fractions are always whole numbers on top, whole numbers on the bottom. But how can we turn the fractions into whole numbers? You might be thinking, well, that's magic. I thought Miss Gannon said we can't just willy-nilly go turning numbers into other numbers. Well, that's a good thing we have math. A fraction bar. Remember, a fraction bar is a division symbol. So whichever fraction bar is separating your numerator from your denominator, that's your division symbol. So you essentially, so if we look back to the top, where 1/2 over 4, that's really 1/2 divided by 4. So what we're going to do is we're going to divide the numerator by the denominator. And remember, dividing by a fraction is the same thing as multiplying by the reciprocal of the divisor. The reciprocal of the divisor. So any division problem in the whole wide world can be turned into a multiplication problem by multiplying by the reciprocal of that second number. So if you remember back to our fractions unit, keep, change, flip is what we think in our brains. Reciprocal, refliprocal, if you remember back to that. When you multiply fractions, so once you've turned it into your multiplication problem, you're just going to have a straight up multiplication problem. With fractions, you multiply straight across. You're just going to go ahead and multiply straight across. So let's take a look at some examples. So we've got 9/10 over 6. Let me get this cord out of the way. I'm charging my phone as I'm recording. I apologize. So let's go ahead and take a look at 9/10 over 6. So this is my big fraction bar, so that's going to be my division symbol. So this is 9/10 divided by 6. Now that's 6 over 1. So I'm going to go ahead and I'm going to turn this into a multiplication problem by multiplying by the reciprocal. So this will be 9/10 times 1/6. I multiply straight across. I get 9/60. I'm going to go ahead and simplify. I can divide both of these by 3, and I get 3/20. That is equivalent to 3/20. Let's take a look at the next one. As you can see, this is the bigger fraction bar, so that's going to be my division symbol. So I've got 20 over 8/15. So this is 20 divided by 8/15. 20 is the same thing as 20 over 1. I'm going to go ahead and turn this into a multiplication problem by multiplying by the reciprocal. So this is keep this the same. Change that to multiplication, flip this guy. Now if you remember back to our fractions unit, we can actually go ahead and simplify this before we multiply it. I noticed that 20 and 8 are both divisible by 2. Actually, they're both divisible by 4. 4 goes into 8 2 times, 4 goes into 25 times. Now I'll multiply straight across. 5 times 15 is 50 plus 25, which is 75 over 2. And now I'm going to go ahead and just turn this into a mixed number. So 75 divided by 2 is 37 and a half. 37 and a half. Bada bing, bada boom. Let's take a look at this last example together, and then I'll leave you alone to do the rest. This is a quadruple complex fraction. Again, this major fraction bar is a division symbol. So this is going to be 6/7 divided by 9/14. So we're going to go ahead and change this into a multiplication problem. We're going to keep change flip. So this is 6/7 times 14/9. I can simplify before I multiply. I can see that 3 goes into 6 twice, 3 goes into 9 3 times, 7 goes into 7 once, 7 goes into 14 twice. That just makes my life a little bit easier. I get 4/3. I multiply straight across. 3 goes into 4 one whole time, and there's 1 left over, 1 1/3. So I'm going to go ahead and leave you to do the last few on your own.